Using substitution, we're going to plug this in for the x on the other equation. So that'd be 4 times 3 minus 1/4 y equals 12. So that's 12 minus y equals 12. Oh, I forgot my plus y, didn't I? Plus y. This whole thing was 4x plus y. Plus y. Negative y, positive y cancel. You're left with 12 equals 12. What does that mean? Infinitely many solutions, which makes this very consistent dependent. Consistent dependent. If all your variables cancel, it's going to be either infinite or none. That one was infinite many solutions, which is consistent dependent. Very good. Questions on that? Today I'm going to show you the method for solving them if neither of those two cases occur. Numbers 20 and 24 were the hardest ones yesterday because the first thing you had to do was solve for y. I'm going to show you a method today where you don't have to do that, and it is called the elimination method. Elimination. And here we go. Now I'm just going to put the answers on the board for these so you can see where we're headed. Here's a good example of elimination. Yes, you could just solve for a letter. In fact, you could solve for both y's and graph it if you wanted to. But here's a way you can do it without doing that. The whole purpose of solving these systems is to find what? That point where they cross. Yeah, the point where they cross. The one point they have in common. So it kind of works out neat when you combine these equations. If I took two equations and combined them, I'm kind of filtering out everything except for what they have in common, because that's like the only part where they intersect. So the point of elimination method is to eventually combine these equations in a way that one of your variables just poof goes away, and you're left with like x equals 4, or in this case 2. And here's how you're going to do that. Now, the beautiful part about this method is you can do it so many different ways. So many different ways. Our goal is to be able to say, I'm just going to take this line, add it to this line, and then one of my variables, like I said, should go away. What would happen if I added these two lines right now? I'd get 5x plus 3y equals 4. And that's just another equation. That doesn't do me any good. But if you remember, the fundamental theorem of algebra is whatever you do to one side of an equation, as long as you do it to the other side of the equation, you haven't changed it. So what if, throwing this out there, what if we took this first equation and multiplied the whole thing by 4? What if we took that first equation and multiplied the whole thing by 4? Now, I just chose 4, but you're going to see why in a second. And I'm going to write that down here. Wouldn't that be 8x minus 4y equals 24? If I took all three pieces and multiplied them by 4, wouldn't that be what I got? Now what would happen if we add it to the other equation? You'd get 3x plus 8x is what? What's 3x plus 8x? 11x. What would happen with my y's when I added them? They would cancel, which is awesome. That's what you want to happen. And then negative 2 plus 24 is 22. Divide by 11, and what does x equal? Which is what the answer is. And then just like before, you have to take that 2, come back up here, plug it into any equation you want, doesn't matter which one, and solve for y. So let's plug it into the top one. So if we plug that into the top equation, that'll be 2 times 2, because I'm plugging in 2 for x, minus y equals 6, which is 4 minus y equals 6. So let's see, I think I'm going to minus the 4. That stupid thing popped up again. Which is going to give me, I'm kind of out of space, I'm going to do it up here. Negative y equals 2, so what's positive y going to equal? If negative y equals 2, yeah, I just changed the signs. Y equals negative 2, and there's your coordinate. 2, negative 2. What? Yes, but we're going to do problems later with like fractions and stuff, and if you did those with substitution, you'd have to take those fractions and like multiply them by everything, and it would be kind of a pain.
How do you know to multiply it by 4? Yeah.
That is a good question. And remember how I said a second ago, this particular method you can do like any number of ways? You didn't have to do it by 4. Now I'm looking at these. Here's now you didn't know to do it on this one, but in the future, in a few minutes, what you're going to be wanting to do is be looking at these equations and thinking, what could I multiply either one or both equations by to where something will cancel? And I said, well, what's the number in front of y right now? 1. 1s are awesome because you can just make 1 into anything. I'm like, well, that's a 1. If I multiplied that by 4, that would be -4, +4, and they would cancel. I didn't have to choose 4. I could have chosen, what's the number that both 2 and 3 go into? 6. I could have multiplied the top row by 3 and the bottom row by 2, and then they'd both be 6s. Of course, I'd have to make one of them negative.
So it just matters what one of them, what either the x or
That's right. You just need to make the x's or the y's equal something completely different, like 4, -4, 6, -6, etc. And you can multiply, one second, you can multiply either row by whatever you want. Let's say that didn't even occur to me. Let's say for some reason 6 didn't occur to me. What if I chose 12? Hey, 2 and 3 go into 12. I could have multiplied this one by 6, this one by -4, and it still would have worked. Yes, ma'am?
Like, what's the other way, like?
Substitution?
There's tons of ways to do this.
That's what I was just telling her. There are infinitely many number choices you can do. I mean, they're all going to work out like that, and you're going to get the same answer, but you could choose any numbers. Let's look at another one. I think if we look at another one, it'll be a little. We'll talk about that one more before we get started.
Do you need to write like?
Yes. Thank you for the reminder. I'm not going to make you, but you just need to know what those are for the test. Now this one. Now this one, there are no ones. You need to be looking at the x's and the y's and be thinking, what are numbers that, first of all, you can choose. Which letter do you want to get rid of? X sounds fine to me. If you had chosen y, that would be okay too. So I'm looking at these x's and I'm thinking, what number do both of those go into?
2.
You're thinking of a factor. You need to think of like a multiple that you can make both numbers into.
24.
Was it?
24.
24.
12.
Or 12. But I heard 24 first. That's what we're going to do. That's what I meant by there's a number of ways you could do it. 24. So, what do I need to multiply the top row by to make it that x equal 24? 6. 6. What do I need to multiply the bottom row by?
4.
Now, that's right, it is 4. However, remember how the last problem, one was positive, one was negative, and they canceled beautifully? You need to make one of these negative because these are the same sign. If you did it just like this, it'd be 24, 24, and when you added it, it would be 48, which doesn't cancel at all. So it doesn't matter which one. Pick one of those to be negative. 4. All right, so we're going to make the 4 negative. Here we go. First, 6 times the top row. That'll be 24x plus 42y equals 36. The bottom row.
Why'd you do 24?
I took this 6 that we chose and multiplied it by everything on the top row.
Oh, I thought we were multiplying it by 24.
No, that's the number we're trying. That's the number that we're trying to get these two things both to equal so they'll cancel.
Why did you multiply by 6?
Because first thing I asked was, what are two numbers? Or excuse me, not two numbers. What's a number that? Because you all chose x. I said, what do you want to get rid of? We're like x. And then I said, okay, if you want to get rid of x, what's a number that both of those numbers goes into? Now somebody said 12, somebody said 24, so I was like, okay, let's just do 24. Because we're trying to make these two things be the same number so that when we add them together, they'll cancel. So then I asked, what do we need to multiply this by to make it equal 24? 6. What do I need to multiply this one by to make it 24? 4. But we needed to make it negative so that one would be positive, one would be negative. All right. Multiplying the bottom row by -4, don't forget the negative. That'll be negative 24x minus 20y. Why is it minus?
Negative.
Because that's right. It's negative 4 times 5. And then negative 80. I multiplied everything by -4. Now, Hopefully at this point you're saying, oh, I can see how this is going to go away. Now when we combine the equations, 24 plus negative 24, those are going to cancel. And then 42 minus 20 is what? 22y. 36 plus negative 80. I think that's negative 44 if you punch it in your calculator. What's that going to be when I divide by 22? Y, yeah. When you divide both sides by 22, y is going to be negative 2, which is what we wanted. Now I need to take that negative 2, just like before. And by the way, at this point, now that you see we've got a coordinate, you could pretty much already say this is consistent independent. But now I'm going to take that negative 2 and I'm going to plug it into either one of my two original equations. Doesn't matter which one. Pick one, top or bottom. I heard bottom first, so I'm going to go bottom. So here we go. 6x plus 5y, but y is negative 2, equals 20. 6x minus 10 equals 20. Add the 10. Oop. 6x, what's 20 plus 10? 30. Divide by 6. And sure enough, x equals 5. Which, yes, a coordinate pair, yes you do. 5 comma negative 2. I mean, I guess I don't care on your homework, but your test is going to be in an ordered pair. Now you could have done that for y. You could have solved the whole equation going for the y's first. What's the number that 5 and 7 go into?
35.
35, yeah. You could multiply the top by 5, bottom by 7, and done it that way. Doesn't matter. You might all do these. Every single one of you might do this problem differently in your homework, but that doesn't make any of them wrong per se. You know, it just all depends on what you're going for. Questions? All right. I'm going to have you try one. Can I take this off the board? Why don't you try that one? See if you can get negative 1 and 5. Doesn't matter how you choose to do it. What he noticed was, remember how the last problem we had to make one of our numbers negative to change the sign? And that's fine. But he noticed, hey, these are already different signs. I won't have to multiply by a negative. I could just multiply them both by a positive because they're already different signs, which I thought was a stroke of genius. Now, if you went after x, that's fine. In fact, I'm going to work it going after x, since like 11 of the 12 of you chose to do that, which is perfectly fine, but I thought that was a really good observation. That can save you a little headache in the future if you go after the particular letter that has a different sign. So what'd you do? Did you multiply you said you made them into 16? Bottom one by 2? Let's see. So going after x, you would have needed to multiply the top one by 3, the bottom one by 5. Which one? Raise your hand if you made the 3 negative. Raise your hand if you made the 5 negative. Looks like it's about even, so I'm just going to make the 3 negative. It doesn't matter. You should get the same thing. Oh, it is, isn't it? So, multiplying the top one by negative 3, that's negative 15x. Let's see, negative times negative is positive 6y. Negative times negative is positive 45. Oops, that should be equals. Equals positive 45. 5 times 3 is 15x. 5 times 8 is 40y. And 5 times 37, so 185. Oh, we have a short class today. I forgot about that. Mm-hmm.
We do have AT time, or is it just homeroom?
Well, homeroom. 6 plus 40 is 46y. 45 and 185 is 230. Divide both sides by 46, and you should get 5. Go back and plug that in for the y. I think the top one would be fine. So it'd be 5x minus 2 times 5 equals negative 15. So that's 5x minus 10 equals negative 15. Add the 10 to both sides. 5x equals negative 5, which I think you can see that x is going to be negative 1 when you divide both of those by 5.
I had a lot of negatives when I did negative 5.
Did you? What'd you say? Yes. I had some more examples I wanted to do. What? Okay. I'll tell you what. I'm going to... What time do we get out of here? Isn't it like 10, 9 o'clock even?
No.
I think it's earlier than that. I think it's like 9:02.
I think it's like 9.
Dang. Tell you what then. What we're going to do... I know, but see, here's the problem. We have done 3. You're right. But the problem is we didn't get into fractions or decimals, which I wanted to. So I'll tell you what we're going to do. I am going to cut down this assignment, but we are going to do those other 2 problems tomorrow. There's your assignment. We're going to do the last 2 tomorrow and then move on to what we were going to do. So there's only 2 other problems.
Do you just do the decimal fractions the same?
Yes, you do. Yeah, you do. But the math can be, people tend to